So today's warm-up is October the 14th. Now, this warm-up is, okay, guys, please stop, guys. This warm-up is similar to what's going to be on your test for this. This will be what we consider an easy graph. Okay, so I want you guys to feel good about this and be able to do this one. It says warm-up, says graph f of x is 3x minus 2 all over 2x plus 1 using intercepts. And asymptotes. Okay, can someone start me off here, please? Someone at random. Foxton. Yep. I'm going to start with it already. Okay, you're not helping me. Foxton, can you give me how to do one intercept here, please? Go ahead.
The y-intercept?
How do you get to one intercept?
For that, x has to be 0.
Good.
So you plug in.
Good. So and therefore we're going to have 0, comma, negative 2. Can everyone agree with that? 0, comma, negative 2. Agree with that? Okay. X-intercepts. Owen, how do we find an x-intercept, please?
So it's going to be a top.
Right on. Okay. So really you're solving this equation. You go across there, so we're going to say x equals 2/3. Okay, so that point is going to be 2/3 from 0. Okay, so that should be back from grade 9, x and y intercepts. That's nothing new. I'm going to start first of all with my vertical asymptote and my horizontal. All right. All right, Riley, what is my vertical asymptote here going to be, please?
X can't equal -1.
Right on. Okay. So this is just your restrictions. We're going to say x cannot equal -1/2. All right, horizontal asymptote, I'm going to do the long way, then I will show you the short way after this. Okay, the long way involves infinity, and I will require you of one question to do infinity on your test. Okay. That said, can we get the infinity way? How do we solve this infinity? Jesse, go ahead. I'm going to start it like this. What happens when I sub an infinity? Yeah, I get infinity. Just start over. Okay. So Jesse, what do we do to deal with that infinity thing?
You do 3x over x.
Yeah. Okay. Now you guys were all filled with holiday turkey, so no one actually fought me on this. So I'm actually cheating here what I'm doing.
Yeah.
Okay, like I'm dividing by infinity, but it's not infinity yet, so I can get away with it. Okay, right? So that's, I'm sort of stretching what I'm allowed to do. It's working because it's not infinity yet. It will be very soon, but because it's not at this moment, I'm allowed to cheat like this. All right, Cole, what is 3x divided by x equal to, please? Okay, minus 2 over x all over. Okay, Nicole, you're not done yet, since that was so easy. What do I do after that? So I'm going to do it twice. I'm going to sub in infinity, and I'm going to sub in negative infinity, because it's still the same equation. So I'm going to say f of infinity equals 3 minus 2 over infinity, all over 2 plus 1 over infinity. F of negative infinity is 3 minus 2 over negative infinity, all over 2 plus 1 over negative infinity. This turns into 3 minus 0 all over 2 plus 0, so we're going to say f of infinity is approximately equal to 3 over 2. Over here, this is going to be 3 plus 0 all over 2 minus 0. So f of negative infinity is approximately equal to 3 over 2. Very, very close to 3 over 2. Okay, so what that tells me, this is the horizontal asymptote is going to be y cannot equal 3 over 2. Okay, Peter, I'm going to pick on you because it's your turn, but coincidentally, you discovered this yesterday. That's the long way to do it with infinities. Peter was doing his homework last night while everyone else was talking at the end of class when I told you all to do your homework. But then Peter said to me, Mr. Sadler, I found a quicker way to find the horizontal asymptote. Peter, what way did you figure out to do? Do you remember?
Well, because at the end of every time, like every time you do the long infinity way, you're just going to get the coefficient of the top divided by the coefficient of the bottom, because the subtraction or addition of the constant values must be zero.
Right on. So what I'm going to say, the short way is going to say, we're going to say, if the degree of the numerator equals the degree of denominator. When I say degree, what do I mean by that? Yeah, the exponent, right? So if it's like x and x, or x squared and x squared, or x cubed and x cubed, okay, we're going to say just the fraction, sorry, the horizontal asymptote is the fraction of the leading coefficients. Okay, so if you take a look here back to this question, what I'm saying is I have 3x minus 2 all over 2x plus 1. The degree is the same, it's an x and an x. So the horizontal asymptote is 3 over 2. That's the short way. Yeah, Nicholas?
So I just quickly too, just to maybe a little bit elaborative, but not much. If we think about this, so in this situation we're putting x equal to infinity, right? So as we learned earlier, this is before doing any math at all. I'm just looking at it from like a more of a theoretical standpoint. You have infinity. As this thing goes to infinity, the only thing that's actually going to matter are these x's and not these negative 2 and plus 1, because what's infinity plus 1? It's still infinity. What's infinity minus 2? It's still infinity. So really, you could just knock off that, and we get the same thing, but just looking at it a different way. So then all that's going to matter is this. And these x's cancel, we get 3 over 2. That's another way of looking at it, but it's the same thing.
You see me saying that, right? Like, it's like 3 times a big amount plus 1 is all the same as 3 times a big amount. Sorry what I was saying. All right, let's get this graphed up and then we'll get on to the homework, okay? So we okay with where, excuse me, those 4 things came from? Intercept should be fine. Asymptotes, just okay where I got the short version. Okay, long version works too. All right. So here's my graph. Now, we will be doing a little bit of graphing again today, so if you don't have graph paper, okay, please go to your neighbor and gently say, hey neighbor, may I borrow a sheet of graph paper?
Hey, you get me a graph paper? Oh, I did.
Foxton, I like how you tried to help your neighbor, though. That was nice. All right, so here we go. I'm going to count by twos. There's a 2/3 in there, I think. But there's my x. There's -1, -2, -3. All right, so I'm going to start with my asymptotes because that's what you always do. I'm going to have y cannot equal 3 over 2, which is going to be right here. So like that. What was x not equal to? Oh, what's the number there?
Negative.
-2 it was?
No, it's negative half.
Oh, -1/2, thank you. Okay, I had a y int of, mine's going blank here. What's my y int?
-2.
Thank you. And we had 2/3 was my x, right?
It's supposed to be 1.5 now.
Is it 1.5 or 2/3?
We actually it's 2/3.
Oh, 2/3.
That's what I thought. Okay, so now we can connect the dots, pretend again you're skating here again, right? The line wants to continue on like this. It can't, so it's just going to curve right along, and it's not going to bounce. There's no parabolas or anything like that. Okay, now just for fun, I should probably do a test point again of. I should probably throw f of -2. Can somebody guess what f of -2 probably is going to be? Just so that I actually do the calculation. What's the value should it have? Hey, Calvin, pick on you because you're actually a Spider-Man right now. If I do f of -2, what should the value be approximately? Should be where?
It would be in the top.
Yeah, it should probably be in the top left. So it should be bigger than 3/2. What's the original equation? I lost my over there. 2x.
3x minus 2 and 2x.
3 minus 2 minus 2 all over 2 times minus 2. So it's going to be -8 over -3, which is 8/3. So we're going to have -2 and 8/3, which is somewhere about here. Okay, which is where it counts at would be, so counts correct. Okay, and we'll just sort of draw a, I guess it's sort of a J-shaped. J's. Good. Now, if I asked you for the domain and range, because I mean like that, because we did the same graph for grade 11s today, and they're freaked out. What would the domain and range of this graph be if I wanted to put it out there? Yeah, go ahead.
X can be anything but -1/2.
Yeah.
Y can be anything but 3.
Okay, now as far as your test goes, this is the type of question that I would be number 1. And I just want to get check, 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 check. Yeah.
I was just wondering, because you said yesterday that it's not technically -1/2, but it's like really, really close to it.
Right on.
So it's not 1/2, so couldn't you technically say X is anything?
No, except for 1/2. It's never going to hit 1/2.
But it's not 1/2.
Right on, that's what I'm saying. So this line's going to hit everything except for, here, except for -1/2. It doesn't actually cross it though, right? Like, if it doesn't cross it this way, okay, so here it's going to be x is greater than -1/2, right? And if this is x is smaller than -1/2, it doesn't actually hit -1/2. You see what I mean? Like that's the point that's missing. It's going to come.
Interval notation?
They have. I'm not going to go there with that right now. I'm just going to stick with this.
It would help that conversation a little bit.
Let's stick with this for right now. I'm not trying to snub you here, but yes.
Yeah, no, that's fine.
Look at that. Okay. Yeah, hey, Joe.
Could you use a little plus or minus thing in trying to make the shape of the graph?
What do you mean, sir?
Interval curve.
Yes, you could go with it. Now the thing is, because this is what, and this will lead us into today's lesson. We're going to do that today, guys. Okay. Because I was looking at what you were talking about yesterday. That's the same thing we're doing today. So, except we're not with graphs. Okay, I'm going to go for number 10 here, and then I'll start today's lesson. So number 10, it looks like was a tricky question. Can I go to the graph here? Rob, any questions, please? Before you announce. Which point? This point or these? Do you hear these ones? So what I just did, I just picked the point to the left of this, just to check if the graph is going to be above or below, right? That's all I checked. Okay, so I picked -2, so I subbed -2 into my equation. So this is my original equation, was f of x is 3x minus 2 all over 2x plus 1. Then I just picked, I could have picked -3, I could have picked -1, I could have picked anything over here, I just happened to pick -2, because it fits nicely on my graph. And then 3 times -2 is -6 minus 2, and blah, 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 blah. All right, this is number 10 from last night. I'm not going to read it out, because hopefully you guys have it written in your notes. After a train derailment in Northern Ontario, this is crazy.
Maybe it sounds like
The concentration of pollutants can be modeled by the function. There we go.
the C in this?
Concentration. Okay, so what was the difficult with this? Sketching the graph? What was the difficult with this one? Yeah.
Sketching the graphs and realizing, like, understanding those 30 gallons per liter.
That is not 30 gallons per liter, 25 liters per liter mean nothing to this question.
Okay.
That's what was confusing.
Yeah, that means nothing to this question. That's okay. This equation works when that happens. Okay. So I just graph this. What happens to t when t becomes very large? Well, it should equal 30. It should go to. It should go to this 30.
For like the graph, yes. Like that, I'm not sure.
Do you want me to do this?
Just the graph.
The graph? Okay. So let's sketch the graph here. We're going to do this the same way as we do before. What are my intercepts here? X int is going to be what? Oh, 0, right? So that's going to be 0, 0. Okay. Okay, my y int is going to be y equals 30 times 0 all over 200,000 plus 0. So y again is equal to 0. So conveniently, the x and the y-intercepts are the same, which makes sense. Okay. All right. Who are we up to right now, Matt? We're up to you. Vertical asymptote from grade 11 is going to be what? Negative 200,000. So we're going to say t cannot equal negative 200,000, which is lucky, okay, because when you're dealing with something like this, well, still you can't go back in time. Okay, so that's okay that you can't go 200. You can't go 200,000 years in the past. Okay, so that's going to be fine. This guy's in physics, so don't worry about time travel here. Okay, now I'd like someone to be brave, other than Peter. Okay, so Peter's out. Tristan, you can take this if you want. Let's do the quick version for the horizontal asymptote. Now you can do the infinity thing if you want to here. Okay, what's the quick version of the horizontal asymptote going to be?
30.
30. How'd you get that?
I took the coefficients of the t's
Right on.
and 30 over 1.
30. So you're just worried about the t's because the t's your lead coefficient. 30 divided by 1 is going to be 30. So we're going to say y cannot equal 30 over 1, which is y cannot equal 30. Okay, so let's just make sure, guys, let's just make sure that we know where that comes from, okay? Again, you're just looking for the t, and the t cancels out. The 1 disappears, right? So the 200,000 disappears, so it's 30 over 1. So this leads to the second part of the question. What happens to t as t becomes very large? When t goes to infinity, what is the y value going to go to? Close to 30. Okay, that's the maximum. Let's go to the graph here then, all right? If we have enough to graph that right there, all right? I'm going to do this very roughly because I want to go here today if I could. This is a very, very rough sketch. Please don't go home and tell your parents that your teacher did a graph this rough.
Oh, it's alright. Should tell them.
Don't you dare.
I'll tell them.
Don't you dare. Okay, so there's my point, which is 0, 0. There's my one asymptote like this. There's my other asymptote like this. The graph's going to look something like that. And then we'll pick another point and line up with that. Okay. So the question would be then, there's a question for the last one that says, when does it equal 0.05? You'd solve that from there. Okay. Is that sort of okay? Actually, I don't close your eyes for a second. I can't tell if I do this something small. Don't close your eyes for a sec. Jesse, that includes you. Tristan, close your eyes. Raise your hand if you feel good about graphs. Raise your hand if you feel okay but use more practice. Raise your hand if you don't like them. Raise your hand if you haven't raised your hand yet. Don't be like that, Riley. And everyone else.
What's the point of closing your eyes if you're going to know?
Because you didn't raise your hand. You have to raise your hand. Okay, that's good.
You did raise your hand. You were right in the college.
I apologize, Riley.
So you were right.
Okay, I'm going to pause them as I do here for these. I will do a little bit more graphs in the future. Today we're taking a break from graphing. We're going to do algebra. Alright, but tomorrow we'll come back to graphing and so forth. Is anyone in this class a long distance runner? Is still leaving tomorrow? Okay. I know you're a long distance runner, okay, but. People